This is section 17.2 about partial derivatives, and we're not going to go very far into it, just a touch of it. So what we need to realize, if z is equal to f of xy, then fx of xy is the partial derivative of f with respect to x. And so y is treated as a constant no matter what it is. Fy of xy is the partial derivative of f with respect to y, and x is considered a constant. So let's look at some examples and see what that looks like. All right, in this example, f of xy is equal to 4x squared minus 9xy plus 6y cubed. Find fx of xy. So that means everywhere there's a y, it's treated as a number, a constant. What is the derivative of a constant? It's 0. So that whole thing, just remember that. So over here, take the derivative of 4x squared. That's 8x minus, now we've got 9xy. Y is a constant, so it kind of hangs out with the 9. So the derivative of plain x is just 1, or the number that's there. So that's negative 9y, because y is considered a constant. It just gets to hang out with the 9. And then this whole derivative is 0. So the total answer for that is 8x minus 9y. Now let's look at that same thing if we take fy. We're going to treat x as a constant. So we've got 4x squared minus 9xy plus 6y cubed. I just wrote it again so we could have it down here. This is a constant. This whole thing's a constant. So the derivative of that is 0. The derivative of this, remember, x is a constant. So that's negative 9y. Let's see. I said that wrong. It's negative 9x because x is a constant and we're taking the derivative of y, so it'll be whatever the constant is in front of it. So it'll be negative 9x plus, do this like we normally do, 18y squared. So that is our final answer on that. Then if we're evaluating partial derivatives, we take the derivative and then we plug in. So if fxy equals this, and we want to know fx of negative 1, 2, we're going to take the derivative of this polynomial, considering that y is a constant. So first we'll find fx. That means we've got 4x plus, now we're taking and we're letting y be the constant. And so the 3 and the y cubed are what's left. If we take the derivative of x, it would normally be 1 or whatever the number is. Well, what's left is 3y cubed. The derivative of 2y is 0. The derivative of 5 is 0. So this is what we've got. Then we plug in negative 1 and 2 to that, and we get the value of 20. Now we'll find fy of negative 4, negative 3. So we first have to find fy. And we're still taking the derivative of this, but x is a constant. So this term is 0. And this one, we've got to think of 3x as just a number, y cubed. So it'll be 9y squared. Well, we include the x because it's a constant. So 9xy squared. Plus, derivative of this one is 2, derivative of that is 0. So here's what we end up with. We plug in our negative 4 for x and our y is negative 3, and we get this. On the next part, we've got second order partial derivatives. And the notes are here for this, but we are not going to cover that in our homework. That's going a little deeper. So the notes are there, but we're not going to do those. So really all you've got to do is evaluating a basic partial derivative. Let's go look at our problems. If we come here, we've got number 1 says z equals f of xy equals, here's our function, and I rewrote it up there in red. Find with respect to x and with respect to y. That's just a different way to read that for 1, 4, and fy 1, 4. So first we have to find the derivative with respect to x, where y is a constant. So this piece would be 12x squared. This piece would end up being a 0 because that's a constant. And then we would have minus 7y. X is a constant. Excuse me. Y is a constant. I just keep saying that wrong. So minus 7y is what we end up here. Then if we take the derivative with respect to y, where x is a constant, this piece is 0. We have negative 18y minus 7x because y is a constant. So minus 7x. And then we're just going to plug in our 1, 4 for both of those, plugging it in here and plugging it in here. And we get our two values of negative 16 and negative 79. Number 2, we have fxy equals 5 minus 4x plus 4y minus 3x squared y, and add a point 2, 3. So what they're saying is find fx of 2, 3 and fy of 2, 3. And the first thing we want to do is find our derivatives. So fx, that's when y is a constant. Well, that's a 0. Then we have negative 4 there. That's a 0. And here the y is a constant. So we have negative 6xy. So that is fx. Then we want to find fy doing the same process. X is a constant. So that's 0. That's 0. Then we have a 4. And in this, the x is a constant. And so it stays there. So we've got 3x squared because the derivative of y would be 1. So we just have minus 3x squared. We're going to plug in 2 for x and 3 for y in both of these. We get negative 40 and negative 8. For number 3, now these, all the answer wanted was the numbers. We had to do the other part. In this part, they are asking for the derivatives and then evaluating at those numbers. But this thing is a product, so that's a little bit harder. We have to make a roadmap. So we've got x cubed e to the 7xy. So my roadmap for fx is x cubed times the derivative of e to the 7xy plus e to the 7xy times the derivative of x cubed. That's the product rule. I didn't take any derivatives, I just wrote my roadmap. In this line, I'm going to take the derivative of this with respect to x. So I write my original, and then when I take the derivative of this with respect to x, 7 and y are both considered numbers, so the derivative would be 7y. On this one, we write that, and then we take the derivative of x cubed, that's 3x squared. Then we just kind of clean that up, so that's the 7 can go in the very front, x cubed y, e to the 7xy. Plus, we usually put the number in front, 3x squared, e to the 7xy. And then you're going to plug that in, you plug in the negative 1 and 5, and we will get our answer. For fy, we end up with, and I didn't write the roadmap here, I just went straight to this line. So we have x cubed times e to the 7xy times 7x plus e to the 7xy times 0. And then that ends up being 7x to the 4th e to the 7xy. That all goes to 0. And we've got to evaluate at 1, negative 4 for that one. So here is where I put in the negative 1, 5 into this derivative. And you could do that on your calculator. 7 times negative 1 cubed times 5e to the, looks like negative 35, plus 3 times negative 1 squared e to the negative 35. So it simplifies to this. And actually they don't want it in the calculator. I was forgetting that. So they don't want a value for e to the negative 35th. This becomes negative 35 of those, excuse me, plus 3 of those. So we have negative 32 e to the negative 35th. When I plug in negative 1, 1 negative 4 into this derivative, I've got that should be a 1 here. That's just wrong. Let me get rid of that negative 1. Didn't change the answer. Okay, so 7 times 1 to the 4th, e times 7 times 1 times negative 4, if we're plugging in negative 1, negative 4. And we end up with 7e to the negative 28, and that is our answer for that one. So number 3, a little bit more involved, and 4 answers to that part. These two were a little bit, this one did have 4 parts, this one just wanted the numbers. But 3 questions, and you are doing a little bit of work on that. But that should do for 17-2.